All right, this is dividing monomials. So the very first step we will do is divide the coefficients, just like you usually would with any fraction. And then we'll use a quotient rule to simplify the exponents. All right, so our quotient rule here is anytime you have x to the a divided by x to the b, what you will do with those is subtract them. So a lot of my students find this lesson really fun, really easy, because it goes from a fraction to just a nice and neat answer most often. So we don't have any coefficients here, so we'll just simplify the exponents. 5 minus 3 will give you 2, x squared. For number 3, if you notice, for number 3, you would still subtract the exponents, and that will be 3 minus 3, which will give you m to the 0 power. But we know that anything to the 0 power is just 1, so our final answer is just 1. Now you could also say from the very beginning that, okay, Mr. White, m to the third divided by m to the third, which is the same thing, is just going to simplify out to give you 1. Yes, but that's because the 0 exponent simplifies out to 1. So for number 5, 6 divided by 2, we will divide those coefficients, and that will give me 3. Don't subtract those coefficients. We are dividing those. We are subtracting the exponents, so that will be x to the first power. For number 7, negative 36 divided by 4 will give you a negative 9. A squared and a squared will just cancel out to leave you with 1, which we don't need to write. And then b to the 5th divided by b to the 3rd, we would subtract those. That'll leave you with b squared. Number 9, 4n to the 5th divided by 8n. So the 4 and 8 can both be divided by 4, which will leave you with 1/2. And then the n to the 5th divided by n to the 1st will leave you with n to the 4th, and that needs to go up top. That needs to go in the numerator because that's the highest. If there was an answer where the exponent was larger in the denominator, then we would leave that in the denominator. Okay, so putting it all together, simplifying these completely, we're going to do one step at a time. So this is really good practice, reviews all of the different properties that we've used so far. So first off, we have this being raised to the second power. So we need to raise 3 to the second power, which will be 9, 3 times 3. And then the 5 and the 2, we are going to multiply those because it's a power rule. And now we just learned dividing. So 9 and 27, we're going to simplify that out just like a fraction. And that would leave me with 1/3 because they both can be divided by 9. X to the 10th, x to the 3rd, that will be x to the 7th up top. So our final answer could just be x to the 7th divided by 3. A lot of times you won't see people putting that 1 there. For number 13, so in the denominator, this is being raised to the second power, so we need to rewrite the numerator. We're not going to use it yet. That 4 being raised to the second power is going to be 16, and these exponents are 1s. So what do we do with those? We multiply. That'll be x to the second and y to the second. Again, this is power rule, not adding. So don't add the 1 and the 2. You're multiplying them. And then we simplify out as much as possible. 12 and 16 are both divisible by 4, so that will give me 3/4. We will have a x to the 7th up top and a y to the 2nd up top when we subtract those exponents. For number 15, we have this whole problem being raised to the second power. So again, if you get confused on this, you can write it twice, right? If we're raising this to the second power, it's just like multiplying something by itself. Okay, so if I was multiplying this as two fractions, I would multiply this straight across. So a good rule of thumb here is we can take 12x to the 5th and raise it to the second power as long as we raise 15x to the second power as well. So we can break it up like this and make it a little easier. We're just raising both of them to the second power. I don't require you to write it out like that. If you want to just go ahead and do it from that first step and skip straight to this one, that is perfectly fine. But 12 to the second power is 12 times 12, which is 144. And then x to the 5th times 2 will give me x to the 10th. From there, 15 to the second power will be 225. And that will be x to the second power. So 144 and 225 are both divisible. Let's see here. Would that be 9? Yep, 9. So if they're both divisible by 9, 144 divided by 9 will be 16. And 225 divided by 9 would be 25. All right, and then from there, that will just leave me with x to the 8th up top. And there's nothing else that we can do there. So 16 25ths and x to the 8th. It is okay if you put that x to the 8th out to the side and just divide that by 25, but understand that you cannot put that x to the 8th on the bottom. It is wrong if you put it in the denominator. It's okay if you put it in the numerator or out to the side. For number 17, so we need to multiply up top. So that'll be 36 x to the 6th, y to the 7th, divided by 6x squared, y to the 4th. So that was just multiplication, no power rule. Now we just need to simplify. 36 divided by 6 will give you 6. That'll be x to the 4th and y to the 3rd. Perfectly fine there. For number 19, this one will be a little fun, but no worries. So 8 times negative 3 will give you negative 24. C to the 1st and C to the 4th will give you C to the 5th. And then D to the 3rd does not have anything to multiply, so we just copy it down. Divided by 6C squared D minus 9C cubed D squared. So we need to simplify this left side. Negative 24 divided by 6 will give you negative 4. C to the 3rd D squared minus 9c to the 3rd d squared. So from there, we do have the same variables and we do have the same exponents. When we are subtracting, we have to have like terms. So same variable, same exponent. We can combine these. That'll be a negative 13 c cubed d squared. So even a problem like that looks crazy to some of you is really not that difficult. I think the most difficult part in that was keeping everything together. But as far as the arithmetic goes, I mean, I asked you to do 8 times negative 3. I asked you to divide negative 24 divided by 6. And then I asked you to do negative 4 minus 9. Really not difficult arithmetic there. It's just a matter of keeping your problems the same, or keeping them separated and understanding what operation to use where. So if you guys got any questions with this, feel free to reach out. I also do have the exponent rules review from Monday.